Assistant Professor, Department of Electronics and Communication Engineering, ATME College of Engineering, Mysore. This is the setup for microwave test bench using Refelex Klystron. This is the laboratory setup which we will be doing in the lab. Let me briefly brief you out with what exactly is Reflex Klystron. Reflex Klystron is an absolute type, the electron beam, which will reflect back the path by the high potential electrode, which is majorly used for creating oscillations. Let me explain you about the block diagram. Reflex Klystron uses this block diagram wherein we have Klystron power supply. Klystron power supply is used to power up Klystron tube, which is fitted on Klystron, mounted on it. And we have an isolator, we have variable attenuator, then we have frequency meter, slotted line section, detector, and the load. Now, these are the blocks which we will be explaining in practical. This is the reflex Klystron supply, which will power up Klystron tube, which is fitted. This is the Klystron mount. This is a Klystron mounted on it, and this is the isolator, which is used to uh, this is the isolator which is placed to pass all microwave signals in one direction only, and this is the attenuator. Initially we'll set up the attenuator to not to attenuate the signal and give the maximum power. Then later we will attenuate the signal. This is the frequency meter where we will be measuring the frequency. Then this is the vernier scale where we will be measuring the uh, distance. Then from here we will be connecting the oscillations to see on the CR. That is the VSWR meter used to measure power of the signal. We will start the experiment in laboratory now. Before starting the experiment, we have to on the fan, which is kept in front of the reflex Klystron. This allows the reflex Klystron to cool down. And there are some conditions to be applied to before switching on the Klystron power supply. Initially, we have to make the beam to minimum and rippler to maximum, and meter select should be on current, and modulation should be AM because we are doing AM modulated signal here. And these are the initial setup before owning the Klystron power supply. Now we are going to on the Klystron power supply. Now we have to wait until we get the current here as 0.010, 010 or 011. Now the current has reached to 0.01. Now we are going to just verify how much is the voltage, and it is increasing, which is 197. Now we have to set the current to 0.012, then check the voltage. It will be 205 or something around that, and we should make sure this particular current should not go down below 210. If we wait, it will increase to 210. And this is the rippler voltage which is there, that is 275. So everything will be set up to this range. Now the meter select is at rippler voltage REP 276. Now we start decreasing the rippler voltage slowly, and we are going to check whether we are going to get the square wave oscillations on the CRO. I am varying the Rippler voltage, decreasing the Rippler voltage until we generate the square wave on the CRO. Now we are getting the square wave on the CRO. Now rotate the frequency meter until we get a dip in the voltage. Start. Okay, there is a dip in the voltage. At this dip point, we are going to measure the frequency from this frequency meter, and we can observe that the frequency will be in the range of 9.63 gigahertz. Now next step is to measure the waveguide of the signal generator. For that, we are going to get back the signal which was to the peak, which we were getting to maximum. Now to measure the waveguide, we are going to use this formula in which we have to measure the distance d1 and d2. The distance d1 is calculated as least count is equal to MSR, that is main scale reading, plus the vernier scale reading. We have the scale here. We are going to move the scale and measure the distance d1 and d2. d1 is for one maximum and d2 is for the second maximum. Move the vernier scale until we get a maximum voltage. Now we are going to measure the D1. D1 is a point where the oscillation on the CRO will be at the maximum point. So we are going to measure that distance on this main scale and vernier scale. From main scale, the zero which is coinciding to the vernier scale, that value we are going to take, that is your D1 value, MSR value, that is 15.6 here. So we are going to take 15.6. That is main scale reading, plus vernier scale reading is the point which is coinciding to the vernier scale. Main scale reading, which is line which is coinciding to vernier scale reading. It is almost coming to 6. So this will be 0.06. So finally the D1 value will be 15.66 distance. Now similarly to this maximum maximum value for the distance, we are going to measure the voltage. How much is the voltage? Here we are getting the voltage as now we are getting Vmax as 20 millivolts into 3 into 20 millivolts. That is the Vmax we are going to get. Next, we are going to see the distance D2, where we are going to get the dip of the voltage. As we increase the distance, we are going to get again a maximum point. This distance we are going to note down again from the same procedure, from main scale reading and the vernier scale reading. So from that procedure, we got the value as So we are getting the distance D2 as 13.6 plus 0.06 that we are going to calculate. So using these two values, we will be calculating the waveguide lambda g by using the formula lambda g is equal to 2 into D1 minus D2. Now for VSWR, we need Vmax, which we have noted down. We have to measure the Vmin for VSWR. We have to check where we are getting the minimum voltage. So this is a point where we are getting minimum voltage. So that particular voltage value is V minimum, that we are going to take the readings. It is 20 into 0.2. 20 into 0.2. So 0.2 into 20 millivolts. So using the formula, we are going to measure the VSWR reading by Vmax divided by mean, Vmin. Next, we are going to measure the attenuation. Now for measuring the attenuation, we are going to take the attenuation reading from this variable attenuator. So we have to give no attenuation right initially, wherein the scale has to be set to 0 here, so that we get a maximum voltage on the CRO. ಎಷ್ಟು ಬಂತದು ಎಷ್ಟಿದೆ ಅದು
3 into 20 milli.
So V max what we are getting, that is V1 is
3 into 20 milli.
3 into
20 millivolt.
millivolts. Next we are going to measure the second voltage in which we are attenuating the signal. So we have to move the scale 5 times until we get the 0. This is first time we are getting 0 on the scale. This is second time. This is third time. This is fourth. And this is fifth. So after 5 rounds, what is the voltage we are getting? Now we can observe the attenuated voltage what we are getting on the CRO. It is measured up to 2.2 into 20 millivolts. Now attenuation is given by V1 minus V2. So whatever difference we are going to get, that is the attenuated signal. We are going to measure the power of the signal which has been obtained on VSWR meter using the VSWR meter scale, which is the second red line. We are going to set to 40 dB as we are getting the reading within that scale, and the measured value is 6.2 plus whatever is the reading here, that is 50 plus 6.2, so it is 56.2 dB we are getting the power. Thank you.